what we were talking about the standard error the previous time and something. So you take standard error is equals to standard deviation over the square root of n. With the example, a firm purchases a large quantity of metal cut-off and wishes to average the weight of cut. A random sample of 65 grams is weighted, and they found that the mean sample weight is 150 grams with the standard deviation of 30 grams. What is the standard error of the mean? So finding standard error in a sample, so standard error is equals to standard deviation over the square root of n, which is 30 over the square root of 625, which is the n. What will be the standard error in the sample size was this. So sample size will already be given, so we'll change this 625, we write here, is it 1025, we get this. So I request you do this sample, you'll have the answers over here. Then you have the estimation of population in proportion. Standard error is equals to P times Q over N. So the thing is, P times Q, we use it when you're doing the estimation of population in proportion. So P, mean of proportion of success, while Q, take 1 minus the P, N is the sample. So example, a random samples of 400 rail passengers is taken at 55% are in favor of a new proposed timetable with 95% confidence. What proportion of all rail passengers are in the favor of the timetable? So a random sample, we have the N, is taken at 55%. The 55% is our P, which over 100, you say it's 0.55. They have done here. Then are in favor of a new proposed timetable with 95% confidence. What proportion of all rail passengers are in the favor of the timetable? N is 400, P 0.55 imetoka hapa. Q 1 minus 0.55 because we say Q take 1 minus P. Unafanya hivyo, unapata hii. So I request, maybe ukikuja Saturday, we will pass through, you ask me questions, then we'll pass through here, you do these questions, you can post so that you can see it. Same to this. Here, a sample of 10 measurements of diameter. A sphere gave mean of this, and the standard error was this. So you still lose the standard error in sampling. Then, after doing that, after doing that, you say like this. And remember, if you're given 99% or 1% or 0.01%, use 2.58. I will explain to you. Okay, then you do this one. Now we go hypothesis. Hypothesis, you'll go and read it all. You know even the process. You know the null. What do they do? Null and alternative, acceptance and rejection. Type 1 error and type 2 error, one-tailed and two-tailed, and this. Test of hypothesis about population mean. So the mean of lifetime of a sample of 100 light tube as produced by a company is found to be 70 hours with a standard deviation of 80 hours. Test the hypothesis that the mean lifetime to tubes by the company is 1600 hours at 95% level of significance. So the mean lifetime of a sample is 100 tubes produced in a company to find out 1570 with the standard deviation of this. Test that the hypothesis of the lifetime has a tube. Now let me tell you a secret. If you see this thing is near the significant level, you remember you do the hypothesis like this. But we are given the you do the estimation of standard error in sample. So standard error is equal to 80 over the square root of 100. 100 metoka, the mean lifetime of a sample, it's 100. So you get 8. Then the population must lie between. So let me give you a secret. So ukiona hiyo the mean life it's 100, and then the company by it is found to be 1570 hours. No, that is our mean, or is it the P, I guess. So when you do like this, 1.96 imetoka from the 95%. If you need explanation, I'll give you the sample and then you explain. As the population mean was this one. You must use if you go through these questions that will give you all the answers, you'll notice the ones which are near the significant level is the ones supposed to be used mostly. So you do this one. I'll explain to you this one. Now the next one is the hypothesis about proportion of population. So the formula is still the same, S is equals to P times Q, but what is going to slightly change here, we use 5% of the significant level. The significant level still we use 1.96, okay, with 0.25. It's still slightly the same. I will explain to you when you're coming back. For any question, I request that Saturday ukue hapa ndio ikuwe rahisi. This one, you do this one. Then we have hypothesis testing between two means. Standard error is equals to A squared over NA plus SB power 2 over NB. S means the standard deviation, population of A and B, and N means the population. When you're done finding the standard error, you find the z-score. Z-score is equals to mean of A minus the mean of B over the standard error. Conclusion, when the z-score is less than the significant level, so the null hypothesis is accepted. When the z-score is greater than the significant level, the null hypothesis is rejected. So a machine of A and B produce identical components, and it is required to test the mean diameter of the component is the same. A random sample of 144, and this is our NA from machine, had a mean now that is our X. You do XA using the z-score, and our standard deviation of, now this is our standard A. So you say standard error is equals to SA squared plus SB squared NA squared over NB squared. They have done here, the formula is here up. You do it like this, then the z-score you do the same. So when you're explaining your answer, you use this. So you do this, same to this. You look at the questions, this one's too, then this one. So we have this. I prefer this one nikuje nikuexplainia ukikuwa shule, because there are some things I need to explain deeper on it. So kindly come on Saturday. We'll do also this one and this one. Then this, the chi-square iko kwa non-parametric parametric test. So kindly you come, then I explain to you on